Good afternoon, students. My name is Samuel Chukwuemeka. I am recording this video on an iPad. I want to see how it will look like. Okay, in this video segment, which I plan to make very short, we shall convert numbers in the binary system to the decimal system. The decimal system is base 10. That's our decimal system. And that is the most common base that we use. That is the most common number system that we use. In base 10, you consider numbers from 0 through 9, which means you consider 0, 1, 2, 3, 4, 5, 6, and the rest of them till 9. Then in base 2, we consider only 0 and 1. Why are we learning base 2? And why do we want to convert numbers in base 2 to base 10? Because the computers and most electronic systems use base 2. Now, if you look at your switch, if you look at the switch in your room or in your kitchen, you see 0 and 1. 0 mean off and 1 mean on. That is because it's in the binary system. If you look at your computer, you see 0, 1. That is because it is in the binary system. Binary system is base 2. You consider only 0 and 1. If you look at base 3, you consider 0, 1, and 2. If you look at base 4, you consider 0, 1, 2, 3, and so on. In this video, we shall just convert from base 2 to base 10. Later on, we can convert from base 10 to base 2. Okay, let's begin. Now, recall. Let's say we have 25. 25 means you can either have it like this, or you can have it 25 in base 10. You can have it this way also. You can also have it like 25 base 10. Now you see that 10 is written as a subscript. Subscript is something that is written under. So you can write it as 10 in figures, or you can write it as 10 in words. Or if you don't write any number system under the 25, it means that it is in base 10. Now, if you're writing numbers in any other number system, you must, and I repeat, you must write the number system as the subscript. You must, if it's in base 2, you must write base 2 as a subscript. For instance, if I want to write 1, 0 in base 2, like I said earlier, in base 2, you consider only 0 and 1. I will have to write base 2. I must write it. If I don't write it 2 as a subscript, then it will be assumed that it is in base 10. If I want to write 1, 2, 1 in base 3, I will have to write 1, 2, 1. I will write 3 as a subscript. Remember, I can also write 1, 2, 1, and I can write 3 in words. So that is it. Let me clear it. So let's go back to 25 in base 10. Let us recall what we learned in the elementary school, elementary grade. You learned about face value and place value. Face value and place value. Wow, this thing writes well. Okay, look at 5, for instance. The face value is 5. But the place value, right, you say 5 is in unit, 2 is in tens. Now, this place value, because it's in base 10, remember, if there is no base number that is indicated as the subscript, it means that the number is in base 10. So this means that this is 10 raised to power 0. Of course, anything raised to power 0 gives us what? It gives us 1. The law of exponent. If you recall the law of exponent, anything that is raised to power 0 gives us 1. And then, so the place value of 5 is 10 raised to power 0, which is 1, which is the unit. And the place value of 2 is 10 raised to power 1, which is the tens. So that means you have 2 times 10, which is 20, and you have 5 times 1, which is 5. So 20 plus 5, 25. So 2 tens and 1 5, 25. The same way we do it in base 10, decimal base, is the same way that if we have to convert from any base to base 10, we will have to do it that way. We will have to find the place value and the face value. Also, remember that anything raised to power 0 gives what? 1. 9 raised to power 0 gives what? 1. 2 raised to power 0 gives what? 1. Samdom, my nickname, Samdom for peace raised to power 0 gives what? 1. Mr. C raised to power 0 gives what? 1. Alright, let's start. The first question, convert the binary expansion of each of these integers to a decimal expansion. So I have 1, 2, 3, 4, 5. Okay, I'm doing number 3A. And this is in base 2, so I have to put base 2. So remember, let me pick a red. Now, this one at the end means 2 raised to power 0. The one following it means 2 raised to power 1. Next one is 2 raised to power 2. Next one is 2 raised to power 3. Then the first one is 2 raised to power 4. You number it from behind. Okay, let's now find the value. So let me pick green. 2 raised to power 4. If you look at your calculator on your computer, if you can get the calculator on your computer, you see y raised to power x. Okay. Okay. I have my computer here with me, my laptop. So I will just go to the start button. If you go to the start button, and if you don't see calculator on the pop-up menu that occurs, you just type in on the search field. On the search field, you type in calculator, and as you finish typing it in, it comes up. You press enter, and of course, when your calculator comes up, it is in standard view. It is in standard view. You don't want to use the standard view. The standard view, some folks call it adding machine. So you click on view. If you look at the menu bar of the calculator that you have, you see view menu, edit menu, and help menu. So you click on view, and you change it from standard view to scientific view. Okay. When you are on scientific view, you will see y raised to power x. Okay, in this case, it's x raised to power y. X raised to power y. So you just press 2, and then you press that function, x raised to power y, and then you press 4, and then you press equal to. So when you do that, it gives you 16. So this is 16 plus 2 raised to power 3 will give you 8, plus 2 raised to power 4, 2 raised to power 2 will give you 4, plus 2 raised to power 1 will give you 2, plus, remember, anything raised to power 0 will give you 1. Anything raised to power 0 will give you 1, plus 1. So this will be equal to 16 plus 8 is 24, plus 4, 28, plus 2, 30, plus 1, 31. And then you can drink some water, some cold water. Okay, I hope you understood this. Now, let's go ahead and check this right away. Before we do more examples. So how do we check this? How do we check it? In your calculator, check. For those of you that probably don't understand what I just said, check, okay? Go back to your calculator and the view, click on the view and change this now from the scientific mode to the programmer mode. And here you are on the programmer mode. So when you do it, it's on decimal base. Now, if you look at the left-hand side, you have the hex. That means hexadecimal base, which is base 16. Then you have the DEC, that is the decimal base, which is base 10. You have the OCT, oct, which is the octal base, which is in base 8. And then you have the bin, BIN, that is the binary base, which is base 2. These 4 bases are very important. These 4 number systems are very important. So it is in the decimal base. Okay, but you want to convert the number from base 2 to base 10. So click on that radio button by binary base. Click on it. And when you click on it, you will see that only 0 and 1 are highlighted. Because in base 2, like I said from the beginning, we consider only 0 and 1. So 2 is not possible in base 2. 3 is not possible in base 2. So let's go ahead. Of course, if you click in base 8, you will see it's only from 0 through 7 is highlighted. 8 is not highlighted. 8 does not exist in base 8. If you click on decimal base, it's from 0 through 9. And if you click on hexadecimal base, base 16, you now have A, B, C, D, E, and F. A means 10, B means 11, C means 12, D means 13, E means 14, and F means 15. That is hexadecimal base. A through F. That's 0 through F. Okay. But we are not worried about hexadecimal now. We can do that later on. So we click on bind and we type in 1, 1, 1, 1, 1. And then once we type it in, we just click on decimal base and it gives us 31. I hope you got that. Good. Now, let's do the next one. Let me clear this. The next one is, let me pause this and write it out. Okay, this is pretty cool. I can pause and begin again. All right, so this is in base 2 and we want to convert to the decimal base, base 10. Okay, so as usual, let me put red. This means 2 raised to power 0. This means 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, 2 raised to power 7, 2 raised to power 8, 2 raised to power 9. Remember, 1, 0, 0, 0, 0, 0, okay, those are the face values. 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, up to 2 raised to power 9. Those are the place values. From 1 to 1 are the face values. From 2 raised to power 0 to 2 raised to power 9 are the place values. Okay? So, this is, you might say that this is real long, but it's not. Okay? Because we won't worry about all these zeros, because 0 times anything will give us 0. So, you go ahead and do 2 raised to power 9 with the method I showed you. This will give you 512 plus, of course, plus 0, plus 0, plus 0. We don't want to worry about that. Then we come to the last one. 1 times 2 raised to power 0, remember it is 1. Anything raised to power 0 is 1. So 512 plus 1 is now 513. Right? Great. So let me do the next one. 2 more problems and we can go. I'll pause it and write it. Okay. This is another question, convert to decimal base. So I'll have to, these are the face values. So let me write the place values. So this means 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, 2 raised to power 7, 2 raised to power 8. And this is your 3C. Yeah, exercise 4.2 3C. Okay, so what is it going to give us now? 1 times 2 raised to power 8, of course, will give us 256, right? Plus 1 times 2 raised to power 6 will give us 64, plus 1 times 2 raised to power 4 will give us 16, plus 1 times 2 raised to power 2 gives us 4, plus 1 times 2 raised to power 0, of course, 1 times 1 gives us 1. So when you add everything, it gives you 341. And then you can smile. And of course, let's check this one. Let's go ahead and check this one. We didn't check the second one, but you can check that on your own. You click on binary again, and you just press 1 0 1 0 1 0 1 2 3 4 5 6 7 8 2 3 4 5 6 1 0 1 binary, and then you click decimal, gives you 341. Yay, we got it right. Okay, let me pause this and do the last one. Okay, let's write the place values of this. 0 has a place value of 2 raised to power 0. This one is 2 raised to power 1. This one is 2 raised to power 2. This 0 is 2 raised to power 3. The 1 is 2 raised to power 4. Let me kind of put it, so I know that it's up to is for 1. Then because I'm not gonna use the zeros. Then this one is 2 raised to power 5, 2 raised to power 6, 2 raised to power 7, 2 raised to power 8, 2 raised to power 9, 2 raised to power 10, 2 raised to power 11, 2 raised to power 12. Now I'm gonna use 1, so I put this here. I kind of mark it here. Then 2 raised to power 13, then 2 raised to power 14. Okay, so what we're going to use is 2 raised to power 14, 2 raised to power 13, 2 raised to power 11, 2 raised to power 8, and 2 raised to power 4. Let's get it started. So 2 raised to power 14 gives, of course, if you do that, 16384. I started writing with red, so let me just write with it. Then plus 2 raised to power 13 gives 8192, plus 2 raised to power 11 gives 2048, plus 2 raised to power 8 gives 256, plus 2 raised to power 4 gives 16. Now let me use green. And that will now be equal to, if you add all of them, it should give you 26896. And it doesn't hurt to check, okay? It doesn't hurt to check. You just go to binary and type this in and click on this and click on decimal, and it brings it to you. Okay, so this is 26,896. This is it. Please, if you have questions, go ahead and ask, and I will reply. Okay, you can go to my website and contact me, or you can also ask me questions on Twitter, or you can email me, whichever one you choose to do. And before I go, let me just quickly give my website. Just go to Google. You can go to Google and type in my nickname, Samdom for Peace. If you go to Google, type in Samdom for Peace. The first link that comes is my website. But anyway, you can also go to the website directly, www.samdomforpeace.appspot.com. That is one of my websites. Thank you for listening, and you have a great evening. Bye.